are sitting in your car at a stoplight waiting for the light to change. As the light changes, a truck passes you in the next lane traveling at a constant speed of 25 meters per second. As soon as the truck is next to you, you hit the gas and accelerate to try and catch up to him. You're accelerating at 4 meters per second squared. Assuming you maintain that constant acceleration, how far will you have gone before you are again side by side with the truck? So here is your car at the stoplight. Here's the truck just as it passes you. And once this happens, the truck is going to be moving at that constant speed. You're going to be getting faster and faster and faster and faster as you catch up. So the first thing we've got to do is we've got to pull some numbers out of this problem. So you're sitting in your car at a stoplight. Well, that means that you're not going terribly fast at that point. In fact, you're not going at all. So your initial speed is 0 meters per second. The light changes, a truck passes you in the next lane traveling 25 meters per second. Now you might notice here for the truck, there's only one V. There's no V0, there's no VF. That's because the acceleration of the truck is 0. No acceleration means the speed is going to be the same the entire time. So there's no initial, there's no final, it's a constant. As soon as the truck is next to you, you hit the gas and you're going to start accelerating at a rate of 4 meters per second squared. And the question is, how far will you have gone when you get back to them? So you want to know how far you'll have gone, and the truck will actually have gone the exact same distance because we're side by side at the start and you'll be side by side at the end. Now what you might notice here is we only have 2 numbers for the car, we only have 1 number for the truck. We do not have enough numbers to solve this problem. Well, we do, but not directly. What we're going to actually have to do is a simultaneous equation. Now here for the car, we want the D, we have V0, we have acceleration. We don't have VF and we don't have T. So the question is, well, what equation do we use when we have 2 blank spots instead of just 1? We're going to take a look at the truck and it'll give you an idea. The truck, we're looking for distance. We're also knowing the velocity, and we don't have time. But what the car and the truck have in common is the truck will be traveling for the same amount of time as the car. So we're going to use the equation that does have time in it and does not have final velocity, because the car and the truck do not have that in common. And that equation would be D equals V0 T plus 1/2 A T squared. And for the truck, the only equation we have for something that's moving at a constant speed is D equals V times T. Now, if you're doing this on your paper at home, what you might want to do is put a little T next to that velocity and a little C next to this acceleration to make sure that you know this is for the truck and this is for the car. I'm not going to write that every time. All my car variables are going to be in red, and all my truck variables are going to be in blue for the rest of the problem. Okay, so now that we have the equations written down, I'm going to simplify this one for the car a little bit. It's going to make our math just a bit easier. And how am I going to do that? I know that the initial speed of the car is 0, so this V0 T term, 0 times anything, just cancels. It's going to make things a little bit easier. So my car equation is D equals 1/2 AT squared. My truck equation is D equals V times T. What I'm going to do is, instead of trying to solve for the displacement immediately, I'm going to solve for the time first, because the math is just a little bit easier. We know that this D has to equal this D. So if the truck's distance or displacement is equal to the car's distance or displacement, that means that Vt for the truck equals 1/2 AT squared for the car. Now what that will look like, I'll move up here to the top right-hand corner, is 1/2 car's acceleration multiplied by time squared equals the truck's speed multiplied by time. Now I can cancel this t squared and this t, which will leave me 1/2 AT equals the velocity of the truck. I can now solve for time. I'm going to divide the 1/2 times the car's acceleration to the other side. And I get t equals v over 1/2 a. I'll plug in my numbers. The truck speed was 25 meters per second, and the acceleration was 4 meters per second squared. And when I plug that in, I should get a time of 12.5 seconds. That means it'll take your car, if you accelerate 4 meters per second, exactly 12.5 seconds until you are side by side with the truck. Now that we have this time, I'm just going to take this and plug it right in to my simplest equation, which is the truck equation. How far does the truck go, which is the same distance the car is going to go, after 12.5 seconds? Well, that's going to be the speed of the truck, which is 25 meters per second, times how long it's going to get to drive, which is 12.5 seconds. And when I plug that in, I get 312.5 meters. And that's how far you'll have gone when you catch back up to the truck.